Hello, everybody. Welcome to section 1.7. This section is on modeling and word problems, and this is part 1 of 2. So, word problems are hard, but there is a strategy overall so that we can break them down and kind of work through them step by step. So, there's some steps for, or like, it's not really steps, but like a strategy for word problems. And they kind of go like this. So the first one is, obviously, read your problem. And then once you've done that, identify the knowns and unknowns, right? So you kind of identify, like, what does the problem give you and what does it want you to find? And then we'll draw pictures and or construct equations. And then solve. And usually you can just solve these equations pretty easily with techniques from section 1.5. And so there's a couple basic kinds of word problems that we're going to go over in this class. So basic sort of types that we will see. We'll see like standard, like pretty straightforward, usually linear problems. And we'll see an example of that here in a second. We're going to do simple interest. Wow. Interest. There we go. Mixture problems. Everyone's favorite. And then in the next video, we'll also see time needed for a job and distance, speed, and time problems. So these are kind of like the basic sort of categories of word problems that we'll be covering in this course. So you can bear that in mind and kind of let that help you figure out like how to solve specific word problems. All right, so let's jump in to actually solving some. So let's go ahead and do like a standard sort of linear kind of regular word problem. So I rent a car for $25 a day and 20 cents a mile. Okay. I rented the car for 3 days. And my overall bill was $122. Okay. I want to know how many miles did I drive? Okay, cool. So let's see, what do we know? We know that the rate is $25 a day. And 20 cents a mile, right? That comes from here, so $25 a day and 20 cents a mile, right? We also know, let's see, I rented the car for 3 days. So we know that I rented it for 3 days. And we also know that my total bill was 122, right? Total, well, was 122. All right, what do we want to know? We want, number of miles. So let's let M be miles. So we're gonna pick a variable to represent. So then we'll use that we'll use whatever equation we construct to solve for that variable. So we know the cost, or like the renting is $25 a day, and we know we drove for 3 days. So we know that that's going to factor in. And then we also know that this adds on to some number of miles times 20 cents, right? And this all added up together should be $122, right? So if we actually write this out, we'll have 25 times 3 plus, and then because cents are out of 100, I'm going to write this as 0.20 times m equals 122. So now we can solve for m pretty easily. And then we will, so 25 times 3, so we have 75 plus 0.2 m equals 122, and then 0.2 m becomes 47, and then we divide both sides by 0.2, we get m equals 47 divided by 0.2, which if you do that division, comes out to 235. So I drove 235 miles. Cool. I obviously didn't go step by step through this division, but when you're doing word problems on the homework or on a test, the numbers should be fairly easy to just kind of do it by hand, to do it in your head. So don't worry too much about using a calculator. You shouldn't need to at any point. Okay, cool. So this was kind of like a standard, like straightforward word problem. It just was like two things added together. Cool. Let's switch gears a little bit. Let's do simple interest. Okay. Now, simple interest sounds scary, but here's the thing. It has a simple formula. I equals PRT. So when you're doing simple interest problems, this is going to be your holy grail right here. And you might be wondering, what the heck do all these letters mean? So P is what they call the principal. And that's how much you initially invest. So how much you invest at beginning of whatever period of years that we're looking at, right? R is the interest rate. So like how fast your money's growing. Now be careful, something like 5%, when you're putting it into the equation, you're going to want it to write it in this form. Okay, so don't put 5 in. Write it like this. Okay. T is time in years, because we're really only going to be looking at interest compounded annually since you've placed, since beginning. And then lastly, we have I, which stands for total interest earned. Cool. So if we know what all these letters stand for, actually, it's pretty straightforward to solve simple interest problems. So let's see an example of that. Let's say I invest $3,000 for, let's do 5 years. And I made $250 in interest. So I want to know what was my annual interest rate. Okay, so remember our equations, I equals PRT. So we know, let's see, we have $3,000 at the beginning. We have 5 years as the time. We know I made this much in interest. So we know the principal, which is $3,000. We know time, which is 5 years. And then we also know I, the interest earned, which is $250. And we want to know the interest rate, so R. So what we're going to do is we're going to plug these in to our equation. So then I equals PRT becomes 250 equals 3,000 times 5. Or sorry, just so I don't confuse anybody, R times 5, right? So we're trying to find R. So now we just solve for R. And so if we divide both sides by 3,000 and by 5, so we get R equals 250 divided by 3,000 times 5. And then there's fraction simplification you can do. And eventually, if you do this by hand, you get out something like 5 over 300, which for this problem, I will plug that into a calculator and you get about 0.0833. So then we can write my interest rate was, and so we move this decimal over 2 spots for percent. Oops. 8.33%. Cool. Again, this problem would have kind of needed a calculator here, but on your homework and on your test, you won't need one. Okay, cool. So yeah, simple interest problems like this are pretty straightforward because they just have one formula. You know what it is. You know what the letters stand for. You'll have 3 out of these 4 things, and you just need to find the 4th. That's usually what they look like. Okay, let's dive in now to mixture problems. And mixture problems are tricky, okay? I'm not gonna lie. They are some of the harder word problems in this course. But here's the thing, we can draw a picture. I draw a picture when I'm solving mixture problems. I recommend you draw a picture when you solve mixture problems. And so let's see what one of those pictures looks like. So let's do an example. Just something kind of straightforward. Let's do what amount of pure acid. So pure meaning 100% acid must be added to 300 milliliters of 50% acid solution to produce a 60% acid solution. So let's do our picture. So in this problem setup, we have this vat here. This is this one is 50% acid. And we know that there is 300 milliliters. And we want to mix it with some 100% acid. We have no idea how many milliliters we need of it, right? That's what we're trying to find. So I'm just going to write X. And then we know we're going to mix it all into a big tub of, we want it to be 60% acid. And we know that the final volume is going to be these two added together. So it's going to be 300 plus X milliliters, right? And so, okay, this is a cool picture and it kind of makes sense, but then how do we turn that into a formula that we can then solve? So here's the kind of the trick is you kind of go down and you're going to do the percentage times the volume plus percent times volume equals percent times volume. So what that looks like for this problem is 50% turns into 0.5. Remember, percents, don't put them in just as the number. You have to convert them into decimals. Times the volume, which is 300 milliliters, plus the percent here is 100, so that's 1 times, we don't know, x equals, and then 60% is 0.6 times, and then I'm going to write this as 300 plus x, like that. Okay, cool. So now we have an equation, and we can go ahead and solve this, right? So I'm going to distribute this into there like that, and so we get 0.5 times 300 is 150, plus 1 times x is just x, and then we have 0.6 times 300 plus 0.6x. And then if we solve further, we can get 150, and I'm going to subtract 0.6x from both sides, so I get 0.4x on this side, and then this works out to be 180. And then 0.4x equals, subtract 150 from both sides, we get 30. Divide both sides by 0.4, we get 30 over 0.4, which equals 75. So we know that x here equals 75. Now, if we go back up, we see our x is the number of milliliters of pure acid we wanted to add to the solution, which is what we wanted to find. So that's good. So now we know I need to add 75 milliliters of pure acid in order to get something with 60% acid. Okay, cool. So that was actually a fairly straightforward mixture problem. Let's take a look at maybe something a little more complicated as our last example for today. So let's see. My 750 milliliters, not all of them use milliliters, but they just happen to both be in milliliters for these problems. Water bottle, let's say, is filled with 75% water. Actually, no, not 75, my bad. 70% water and 30% orange juice. Not a very appealing mixture. But anyway, I want a 40% orange juice. Oops. Concentration. So I want to somehow make it so there's 40% orange juice and 60% water. My friend is letting, oops, letting me use their 60% orange juice mixture. So what I'm going to do is I'm going to use this 60% mixture and I'm going to supplement some of it into it to get it to bump it up to 40%, right? But my water bottle's full. So how much should I drain from my bottle and replace with the 60% mixture? Right? So this one, long and also pretty complicated. There's a lot of numbers going on. There's a lot of different things. We're not just adding two things together, we're draining some things away. So let's take a step back and let's draw a picture. So in this one, this is going to be my water bottle. So my bottle. And then over here, I'm going to have not my friend's water bottle, but the amount that I'm taking from. So added mix, right, from their bottle. And then what they're going to be mixed together. So, well, I know that the water bottle is 750 milliliters total, right? And I know I want 40% orange juice. Oops. Right? And then in my friend's mixture, I don't know how much I want to add, but I do know that it is 60% orange juice. And then for my water bottle, or at least I shouldn't say my bottle. It's more accurate to say my mix, right? So after I drain it out, right, how much of like my 30% mixture is going in to my new bottle, right? So we have the 30% plus the 60%, and I want to know how much of each do I need to use in order to get a total of 750. And so if you remember our kind of trick from earlier, this becomes 0.3 times 750 minus x plus, and this becomes 0.6 times x equals 750 times 0.4. Cool. Now we have an equation and we can just solve for x, right? So if we follow some steps, I'll distribute this into here like that. And so I get 0.3 times 750 minus 0.3x plus 0.6x equals, and then if you do this math right here, you should get 300. And then this comes out to 225. And then if I add these together, I get plus 0.3x equals 300. And then I'm going to subtract 225 on both sides, so I get 0.3x equals 75. And then divide both sides by 0.3, so I get x equals 75 over 0.3, and then this will eventually equal, if you do this math, 250 milliliters. So what was x again? Oh, let's scroll back up, and it's how much I needed to add, right? So it's how much I need to drain away and replace. So I need to drain and replace 250 milliliters from my bottle. Okay, cool. So mixture problems, they can be a little confusing and they can be long, but if you draw a picture, that will get you an equation. And so that's what I really recommend doing. Next time, we will go over the time to do the job and distance, rate, and time problems. But until then, good luck on your homework, and I will see you in office hours.